The next claim that I want to prove is that the number of triangles in a triangulation is always n minus 2. This is much easier to prove than the previous claim, so let's go through it. We're going to use induction. For n equals 3, this is obvious because then the polygon is just a triangle, and a triangle has only one triangle, and 3 minus 2 is 1, so it holds. So now let's assume that it holds for any polygon with n vertices. N vertices or fewer than n vertices. So we have a polygon with, say, n plus 1 vertices, and then I know that I can make a connection between some two vertex in the polygon. So like I can connect P to Q. That cuts the polygon into two pieces, a polygon P1 and a polygon P2. By induction, both P1 and P2 is smaller than polygon P, and the reason is that they will have at least one fewer vertex. So in particular, if P2 is a triangle, it means that P1 will have one fewer vertex. It means that this vertex is not part of P1. Okay. In general, if the size of P1 is n1, and the size of P2 is n2, then n1 plus n2 equals n plus 1. Well, n is the size of the polygon P. So here I've assumed that size of P is n. Okay. Why this equality holds? This is because every vertex of P1 and P2 is counted exactly once, except these two vertices. These two vertices are counted twice, both in P1 and P2. So therefore, when I count the number of vertices of P1 and P2, I will get n plus 2 vertices. And since the size of each one is at least 3, therefore P1 and P2, they're both smaller than n minus 1. Right? Because I know that they sum to, because n1 plus n2 equals n plus 2. And I know that n1 is at least 3, so therefore n2 is at most n minus 1. And similarly, you can show that n1 is also at most n minus 1. So I can use induction. So I can essentially have proven this inequality. So now I can use induction. So therefore, P1 can be triangulated into n1 minus 2 triangles. P2 can be triangulated into n2 minus 2 triangles. And then you add them up. So the total number of triangles is n1 minus 2 plus n2 minus 2. And since n1 plus n2 is n plus 2, one of those two cancels and I get n minus 2. And that essentially is the proof that the number of triangles in any triangulation is the same.